Okay, welcome to the hardware party. When you look inside a typical computer hardware, you're going to see something that looks like this. And this is a giant network of complex electronic circuits. And yet, some way, somehow, which I will call magical, through some magic, this gets executed on a hardware that looks like this. And so in this video, I want us to take a look at a super high level overview of what actually goes on. I mean, how come the test that you specify in a Python file gets executed by a computer hardware, which is some serious network of complex electronic circuitry. Okay? And to describe that to you, I want us to go to Wikipedia and I will use an image that is a description of a computer architecture called the von Neumann architecture. If you want the details of what the von Neumann architecture is, which I highly encourage you to do, then you want to read this article on Wikipedia. But in this video, I'm just going to spend time with the image, okay? All right, so if you take a look at the hardware of a computer like we saw on this screen, okay, we can use this block diagram here to explain what happens in this giant network of fantastic electronic circuitry. So in the hardware, there are slots for inserting your memory, which is the RAM. There are connection points for input devices like your keyboard and your mouse. There are connection points for output devices like your monitor or your speakers. And some way, somehow, all these, devices on the motherboard are able to communicate together. And so we are going to use the von Neumann architecture to explain how communication happens between different components on the computer hardware and how your program statement also get executed. So this is the a block diagram of the von Neumann architecture, and you can see that there is a connection between an input device and your central processing unit. This is actually where most of the magic happens. And then there is also connections to output devices. Now, the connections are called buses, okay? Like buses, like the buses you know that run in your city. I mean, come to think of it, what do buses do? They carry people from one place to the other. And so in the computer hardware, the buses are physical connections. Think of them as wires. If we should take a look inside the motherboard closely, you would see that there are some thin wires that are running all over the motherboard. Okay, and some of these thin wires are actually buses, and these bus lines basically carry information from one component on the hardware to another component, and sometimes they are bidirectional, so it can carry information to or it can carry information from. So we have these input devices, and then we also have output devices. Where we want to focus our attention on is on the central processing unit, because that is where most of the execution of our programs actually happen. And your central processing unit, which is also known as the CPU, communicates with one key component on your hardware, which is called the memory unit. And the memory here is referring to your RAM, which is also known as the random access memory. This memory is also sometimes known as the primary memory. And then we have more persistent memories like your hard disk or your floppy disk. I mean, most of the people now do not know what a floppy disk looked like, but it was also a storage media. And these secondary memories are persistent. And when I say persistent, what I mean is they are able to retain the information that they store even when you take power out of them, like when there is no current or electricity running through them. Through some other technology, sometimes it is magnetic, sometimes it is optical, they are able to retain the information that are stored on them. But we want to focus on what happens between your processor and your RAM, which is also the primary memory. Another way we describe the RAM is we say it is ephemeral. When we say something is ephemeral, it basically means that it loses what it contains when you take power out of it. And so whatever is in your computer's RAM is going to go away when you shut down your computer. And when you start your computer, new things quickly fill up your RAM depending on the programs that you are running. Okay, so when you write a program like we have done here, okay, what is actually going to happen is, first of all, our program starts out being a source code, and the source code is sitting in a file, and this file is sitting on the hard disk. Okay, so the program is a source code that is sitting on a secondary memory, which is a hard disk. So now this hello.py and hello.py are actually sitting on my hard drive. Okay, now when we execute the instruction, this instruction, let's say python hello world.py, what is actually happening is that the program statement inside the file hello.py are going to be loaded from the file. And remember, the file is sitting on the hard disk. Okay, so all the program statements in the file are going to be loaded into the primary memory, which is what? Your RAM. Okay, so all these instructions are going to be loaded into your RAM. And then comes the communication strategy between your RAM and the processor, because the part of the hardware that actually does the execution of your program statement is a subcomponent of your central processing unit, which is also known as the arithmetic logic unit. That is where all your calculations and logical statements are going to get executed. Okay, so that is where the actual execution is going to happen. Now, sometimes you also have program statements that put information in the RAM. So remember, your program statement themselves are sitting in the RAM. Okay, and so the ALU, or the arithmetic logic unit, has to constantly be coming to the RAM to fetch instructions that it is going to execute. And yet there are other program statements, which we'll learn about later, that actually instruct the processor to put information somewhere in the RAM. And so there is this bidirectional communication between the RAM and the central processing unit. It is either coming to fetch an instruction, or it is coming to put data inside the RAM. And then inside the processor again, we have another subcomponent called the control unit, which is also a serious electronic circuitry that contains it has the ability to control how the other components of the computer works together. So things like timing, it is the one that controls when the processor has to go and fetch information from the RAM, or when some instruction has to be fetched from the RAM, or when an input is ready from an input device, or when something has to go to an output device. So it is like the boss, okay, controlling the affairs. And it is not just the boss in the wrong connotation of the word, but it is the boss in the sense that it keeps things running. It determines the order in which things are happening. And so this control unit and the arithmetic logic unit are both sitting in your central processing unit, and the bus lines, which are scattered all over your computer's motherboard, is how information is moved between two components. And then we have this memory unit. This memory unit is very important because that is where your program instructions are going to be sitting after they are loaded from the hard drive. And also that is where you can write program statements that are going to store some information into your RAM. And we'll start talking about that very soon. But I just want you to have this super high level overview. Of course, what we know now is going to be different from what a certified hardware engineer knows, because they know a lot more details. But for us as software engineers, we want to be able to at least bridge the gap between what happens after I have typed my source code to actually getting it executed on the hardware. And so when the Python interpreter loads these instructions and convert them to the bytecodes, which are instructions at the level that your processor can execute, those machine level instructions are loaded into your memory, and then it is going to be fetched and executed by the arithmetic logic unit one after the other, whilst the control unit also does the work of ensuring that there is order and not chaos in your computer. So I hope this helps you to break the gap, and thank you very much for staying with me, and I will see you in the next video.